Hi guys, my name is Felix from examsconnect.com, and today we are going to look at physics, and I want to introduce physics with the key three topics, which are force, motion and energy. So welcome. So when you talk about physics, it is a very interesting subject. Most of the phenomena we see around are around physics. When you look at the bulb, when you look at the video that you're watching right now, when you look at the phone, maybe your parents' phone, the TV, just think of any modern technology, and that is physics. So my main topic for today will be dealing on motion, forces and energy, as I had said. But first I want us to define a little bit about physics. And when you look at physics, it is a branch of science that deals with matter and how it relates to energy. So you're looking at matter and how it is relating with the energy around it. So we're going to be able to explain some phenomena. For example, the rising of the sun, the formation of rainbows. I know that most of us are awed by the rainbows. And how do they form? And remember that this is also part of physics. Next, we're going to look at some very interesting scientists who have also gone further to discover more about physics. We have Isaac Newton, we are aware of him. We also have Mike Faraday. He is responsible for the electricity that we use. We also have Einstein. You know Einstein is responsible for relativity, a very interesting topic in physics. So all in all, physics is very easy because what I'll be giving you is the concepts, the physics concepts. So your work is to take them, you understand them, and maybe you work out some few examples. And then with a lot of practice, you also become an expert in the subject, in the field. So my main issue here is to give you the concepts, the physics concepts. You have to understand them. Don't cram them, just understand them. Then have some few examples. Then from the examples, you just practice. You need to keep practicing them until you become an expert in physics. So the willingness in you is what we require in our introduction in physics. You also need to be willing and also adventurous out there. You need to know some phenomena. So physics is divided into different groups. Let me start with the first group. The first group of physics, which I'm going to call physics 1. Now physics 1 is what I'm going to start with. This is physics 1. It entails force, motion, and a little bit of energy. That is physics 1. This is basic physics. We also have physics 2. Now in physics 2, we are going to handle thermodynamics. We also have waves, is also handled under physics 2. Next, you also have physics 3 that you also handle maybe in your schools. This is concerning electricity, which you're going to do also. Electricity and magnetism. Remember that we're just trying to introduce the whole physics, and we just look at the main categories. So when I talk of physics 3, I'm talking of electricity and magnetism, and here we deal with fields, the fields that are involved and how they interact. Later you're going to discover that magnetism and electricity are correlated. One causes the other. And we are going to see how we can create electricity using magnets and magnets using electricity. Next we have the last physics that is known as, the last group known as modern physics. Under modern physics, also some people like to call it physics 4. It deals with more advanced physics, maybe not at our level here, relativity and quantum physics. Quantum physics. And these are very interesting topics, especially relativity, because in relativity we are talking of the likes of how time is able to shift depending on the condition that you are in. You notice that even when you are doing something interesting, maybe swimming, maybe you are doing your hobby, time tends to run very fast as compared to when maybe you are doing some stuff that is not as interesting. That is more of relativity physics. Then we have quantum physics, talks of the issue of, maybe I can give an example of light. Light is said to be a wave, but also at some scientists claim that light is a form of particles that are traveling, but they come to an agreement that they can have physics explaining it under the quantum, that it can either be a wave or it can also be a particle. So that is dealt in under quantum. So I think with that, we can start with the first part, which is motion. Motion, remember that it is under physics 1. So when I talk of motion, what do I define as motion? It is a movement. It is a movement. So we start with the first part of physics, which is motion. The first part of physics, which is motion. And what do we need to know about motion? First of all, we need to look at the equations of linear motion. This is motion in a straight line, equations of linear motions, because there are different forms of motions. Motion can also be circular, where we have a wheel moving round. However, there is a relationship between circular and linear motion, because when you look at a wheel in a vehicle, the way the wheel moves is a circular motion, yet it causes the vehicle to move in a linear motion. So the three equations, there are just three. We have the first one, the second, and the third. The first one is V is equals to U plus AT, where I want to define at least each of these terms. V represents the final velocity that the body will have attained. U represent the initial velocity that the body started with. Then we have A is the acceleration, and we have T as the time taken for the body to move. That is V is equals to U plus AT. That means that final velocity is equals to initial velocity plus acceleration multiplied by the time taken. Next we have V squared is equals to U squared plus 2AS. U squared, V squared is equals to U squared plus 2AS. Now this is the second equation of linear motion. And remember that when you're talking of linear motion, we're just talking of motion in 1D, in one dimension, motion in one dimension. So we're saying that when you square, remember that every term here, except for S, which I have not introduced, S is just displacement, or the distance covered by that body. So this means that when you take the initial velocity, the final velocity squared, it should be equals to initial velocity squared plus a product of 2 times acceleration times the displacement that has been moved. Then we have the last equation of motion, S is equals to UT plus a half AT squared. S is equals to UT plus a half AT squared. And this means that displacement is equals to initial velocity times the time taken plus a half of acceleration times time squared. Maybe I can give a simple example, because most of these are just algebraic equations, meaning that you can make any of these values the subject. Let me give an example using the first equation. Now, when you total V is equals to U plus AT, I want to give a very simple example. Calculate the final velocity of a body that started at rest and accelerates at 10 meters per second squared by a time, maybe a time 3 seconds. Calculate the final velocity of a body that started at rest and accelerates at 10 meters per second by a span of 3 seconds. Now, that means that we need to apply the first equation of motion so that we can have it as v is equals to u plus 80. V is equals to u plus 80. So I'm trying to calculate the final velocity, which is now v. And I have, so this in the solution we have u is 0 meters per second because the body was at rest, so it was not moving. We have a is equals to 10 meters per second squared. Then we have the time as giving us 3 seconds. If we substitute that in our equation, then we can have it as v is equals to 0 plus 10 times 3. That gives us 30 meters per second. So that's how you apply the linear equation algebraically in an example that you are given, maybe in your exam, so that you can solve the final velocity of this body.